Fantastic. So I'm not sure if this is something you've seen before. Maybe have, maybe haven't, but these are basically two methods. Um, I wouldn't necessarily call them methods, maybe more like
Hmm.
tricks that just help to make integration by parts like a lot easier.
Yeah.
So the first challenge that really comes up is obviously figuring out what to pick as u, right? And let's like kind of go through that first. So when it comes to like picking a value for u, most of the time, um, like people don't really have a set structure, like a set way of thinking. And there's an anagram or like a memory technique that I use to basically pick a good value of u. So what it is, it's LIATE. Okay, so
Hmm.
LIATE. Okay, and this is in order. It's similar to like BidMass in that sense. So at the top, you've got logarithmic. Okay, and then it goes down. And effectively, what this helps you to decipher is what you should be picking as u. Okay,
Yeah.
so what you want to see firstly is okay, um, okay, I picked my u. We've got the u here, and then obviously the other value is going to become dv by dx. So um, that's that's effectively the way I use this. So how does this look in actual practice then? So in actual practice, let's say we've got x squared e to the x, right? If we go back to our Liates example here, algebraic, okay, we've got algebraic here. Okay, we've got x squared.
Yeah.
So we can put x squared there. Exponential is e to the x. Okay, so that's right at the bottom. So x squared is going to be our u. Okay, exponential dv by dx. Okay, so that's the first kind of challenge solved. Is what do we pick as u? And using this anagram, Liate works a charm because it's just really like useful to
Hmm.
um basically decipher, on the spot. A lot of people waste time like trying to figure out what to pick. This just helps
Yeah.
you to immediately kind of figure that out. So the second bit here is okay. Um, there's examples where at least I've experienced them where like you're going through, it's a stress of the exam, things are tough, and basically, the clock's running down. You're doing integration by parts, and next thing you know, you have to do like a bunch of new integrals or whatever.
Yeah.
And like you can make it's really easy to make like silly mistakes.
Hmm.
That's something you've experienced at all, or are you
Yeah.
okay?
During mocks. Yeah.
So there's a method, and again, I'm not sure if they've shown you have they shown you this method at all? The type of the method?
No, I think my teacher must have covered it, but he goes like really quick, so I definitely didn't remember.
Sure, yeah. So this method here is basically this is a bit of a cheat code, because
Hmm.
what this helps to eliminate is that kind of like not unstructured but rushed way of doing integration by parts where it's very easy to make mistakes. So for instance, when you've got like multiple integrals, like let's say you've integrated it already, and then you've got
Yeah.
a new integral you have to do, and then you have to do a new integral, right? And then eventually you get to the answer. This just helps to really like simplify things down. So let's say we've got x squared e to the x, right? The first thing you need to do is we're going to draw a table, okay? And on the one column, we're going to have sine here. The next column, we're going to have a differentiate column. And on the column right at the end, we're going to have the integral column. Now, what does this mean?
Hmm.
If you remember before, in this example, x squared e to the x, we have picked the algebraic function, which is x squared, as our u. So what we're going to do is we're going to put our u in the differentiate column. Okay. And we've picked the exponential function, which in this case is e to the x. we're going to put that in the I column. Okay. So we've got u dv by
Yeah.
dx, and we're putting e to the x in the integrate column. And right at the end, we've got a sign. Now, what does this mean? Effectively, what this does, it kind of automates the integration by parts process. So the first thing you want to do is in your sign column, we start with a plus, then we go minus, then we go plus again. And you want to keep going. Actually, I'll get to that in a second. But effectively, just do plus, minus, plus, minus, plus, minus. Obviously, don't go on forever, but
Mm.
because you'll see in the next part when you know how to stop. But just set it up with plus, minus, because that's what you're going to be doing. You'll be alternating between plus, minus, plus, minus. Okay. Now in this column here, it's differentiate. Now we've got u here, which is x squared. Then we've got the integrate column, which is e to the x. What we need to do is we are going to, first and foremost, we're going to differentiate sequentially in this column. Okay, so we
Mm.
differentiate x squared to get to 2x. We differentiate 2x to get to 2. And then we stop when we get to 0, because obviously there's nothing else to do there.
Yeah. Yeah.
So that's the first step. Okay. Any questions so far? Or you kind of feeling good?
Yeah, I understand it so far. Yeah.
Okay, brilliant. So that's the step there. Now on the integrate column, you're obviously just going to integrate. So we're going to
Mm.
integrate e to the x, and then we're going to integrate this. Well, e to the x integral is e to the x, e to the x. Okay, so this one's a pretty easy one. Cool. And obviously we've stopped at 0 over here, so this is going to be our final. Now, this is where things get kind of fun because what you'll see is that things become so much quicker. What I'm going to do is I'm going to do a cross multiplication.
Mm.
Okay. So the first thing I'm going to say is what we have is plus x squared e to the x. Okay, so I times x squared by e to the x, and I put a plus in front of it, which is represented over here. The next thing I do is I do e to the x times 2x, and I put a minus in front of it. And after that, what I do is I do 2 times e to the x, and I put a plus in front of it. So as a result, what we get in our final answer here, and I wish I'd had my iPad, I could link it to like do this properly from the thing, but
Yeah.
I've had to rely on slides here. Um, is basically we get a final answer, right?
Mm.
And that was basically done just by looking at this table and
Yeah.
multiplying, right? So pretty neat. Any questions from that before we get to the next example?
So for this method, because it's much quicker, do I need to write anything else apart from this over here? Do I need to like label my U's and my V's to get like all my method
Yeah,
marks?
yeah. So what you
Okay.
need to do is, so the Edexcel are pretty clear about this. This method is applicable.
Yeah.
You can use this.
Okay. Okay.
You just have to be, as always, just like with any kind of working, you need to be very like explicit about what you're doing. So I'd maybe even say like in the beginning, like using tabular method dot dot dot, and then you
Mm.
can kind of do it from there. But yeah, be explicit as what you're calling U and
Okay.
U beta X.
All right.
It's always, I mean, always like err on the side of like being as precise and thorough as possible.
Yeah.
So you never know where those method marks can come from in many cases. So
Yeah.
yeah, always be as precise as possible. So another example, right? We've got x squared times e to the negative 3x. Now it's a similar type of example here. X squared, that's obviously going to be our u. E to the x, or sorry, in this case, it's e to the negative 3x. That's obviously going to be dv by dx. Okay.
Mm.
And so, what do we do? Well, we draw our table, we do our signs, and we say, okay, well, u is going to be over here, dv by dx, it's going to be over here. So we've got u, x squared over here, divided by the x over here. Now, very simple. We just integrate in the d column, sorry, differentiate in the d column until we get to 0. And in the I column, we just integrate until we are matched up over here. So when we do that in this example, it's just a basic kind of integration. So first we integrate e to the negative 3x, so we get negative a third e to the negative 3x. Then we integrate negative a third e to the negative 3x to get to a ninth of e to the negative 3x. Okay, then we integrate a ninth e to the negative 3x to get to negative 1 over 27 e to the negative 3x. Okay, and we've stopped here because it's on the same row as the 0, right?
Yeah, zero.
So what is a question for you, Tammy? What's the next step here? I know it's kind of obvious from the slides, but but
Simplest form.
what's that?
Like, would you like expand it out and then put in simplest form and then add plus C?
Exactly, but how do we expand this out?
Um, you just timed all the values together. Like, was the x? Can you wait? Can you put all the x squareds together with the e to the three x's, and then you factorize e to the minus three x over 27 out, more negative e to the minus three x over 27.
That's right. But like, how do we get from like this to this? Do we just like
Oh, okay, no. So you diagonally down,
okay,
diagonally
cool,
put it down to the like bottom row,
awesome.
to the
So
row below. Yeah,
exactly. So what we're gonna do very simply is x squared times negative a third e to the 3x, negative
hmm
3x, sorry, times here. And we always put, it's very important, right? The signs are very important. These aren't just like placeholders, like they're very important to have.
yeah,
So we do plus x squared times negative a third e to negative 3x
yeah,
minus 2x times a ninth e to negative 3x plus 2 times negative 1 over 27 e to the negative 3x. Okay, and then from there, we're able to get to there. Now, this all looks well and good, but are there any like anything you can think of where like any situation you can think of where this could all fall apart?
um, the integration by parts questions where it goes in like a cycle and you have like the I method and you go like
Perfect.
2i
Yeah,
equals, yeah,
smashed it, smashed it. So that's exactly what this bit covers now.
yeah,
So in this case, right, let's say we've got e to the x cosine x. What we're going to do, we're going to get back to LIATE. Okay. Um, Let me just get my razor here. Okay, what do we have here? E to the x cosine x. Okay. Right, so cos is obviously a trig function. Okay.
mm,
So we can put cos as u, and we have a exponential here as well. So exponential is obviously going to be dv by dx. Okay,
yeah,
cool. And so what does that mean? Well, we just do exactly what we did before. Do plus minus, and then in the differentiate column, we're just going to keep differentiating. But the challenge, as you mentioned, is that it's cyclical. Okay, so what
yeah,
happens here? Well, the trick here, let me just move this. Can you still see me?
yeah, I can still see.
Okay, cool. Yeah, so the trick here, okay, is to basically realize that, okay, we've gone through differentiation here and we are back
Hmm.
at cosine of x. Now it's not plus cosine of x is negative, but that doesn't make a difference here in the sense of well, it does make a difference, but like what we are really interested in is it a multiple, right? So
Yeah.
we don't stop the cycle when it is just cosine x. We stop the cycle
Mm,
when it's negative cosine x or cosine x, right? So
okay.
but in this case, obviously, it's always going to be negative cosine x. So what's up the intuition behind this, right? Well, the intuition behind this is if we keep integrating e to the x here, and then what we're going to have, okay, is negative cosine x times e to the x. Now remember what we're trying to solve. Our integral itself is e to the x cosine x. Okay, so we have I
Mm,
is equal to e to the x cos x. Then if we have a negative in front of this, right, then we have negative I.
negative I. Yeah.
So what that means in this example is that we're going to do our multiplication as we normally would. Um, let me just, we'll do the multiplication as you normally would, but we have a plus minus I
Okay.
here, right?
Yeah.
And so as a result, we can simply take the I over, we get two i's equal to this. So we solve for R. And that's our
Mm,
integral.
yeah.
Um, all good so far? Any questions on that?
Yeah. Yeah. It's much clearer now with this method.
Nice, nice. That's good.
Yeah.
That's good. And what I'm going to do now is I'll walk you through an example where
Okay.
this is basically conveyed like to an extreme form, right? So
Yeah.
if you to do this manually, it obviously you get a bunch of integrals and it take a while.
Yeah.
What this shows now is the simplicity of this. So again, we do the signs. We got our derivative column, we got our integral column. What we're going to do is we're going to go to our LIATE. Okay. Let's say, okay, what do we have here? Well, u is going to be sine x, right? Because it appears above the exponential.
Yeah. Yeah.
Meanwhile, um, x3, that's algebraic. Oh, sorry, no. Sorry, I meant that's stupid. Hang on. So we got algebraic above. Sorry, I thought we had an exponential there.
Oh, yeah. Yeah.
Okay, so just to double check, what we've got here is x cubed. Okay,
X cubed. Yeah.
so x cubed, and we got sine x here. Okay, so that's u, and then we got dv by dx here. So what we're going to do is we're going to put x cubed in the d column and sine x in the I column. Do the signs, and we just do the same thing as we normally would. X cubed, 3x squared, 6x, 6 sine. Okay, and obviously the alternating signs. And
Yeah.
we're going to finish again once we get to zero for the derivative column. The integral column doesn't make a difference here. It can go on forever.
Mm.
We always stop when we have
When it
zero
gets to zero.
or
Yeah.
the multiple of, yeah, for cyclical ones. So from here, we just do again plus x cubed negative cosine x, then minus 3x squared times minus sine x, then plus 6x cosine x, then minus 6 sine x. And then put all together, and we get this. So yeah, any questions on that one?
So, what happens if your U is negative?
Your u is negative.
Yeah.
That shouldn't make a difference.
Okay.
Yeah, it- Is there any reason why you asked that?
Because negatives is what usually gets me out in an exam. It's just the
Gets you what?
signs that usually get me an exam. It usually that's what usually makes me lose marks because I don't identify the negatives correctly.
Right.
Mm.
Yeah. It doesn't make a difference. I mean, I'll double check, but I mean, from my understanding, yeah,
Yeah,
remember you is a function, right? So
yeah,
obviously the function negative x is different. So we have y is equal. If we have y is equal to minus x and y is equal to plus
yeah,
x, these are two different functions. So
yeah.
um, what LIATE deals with is the function itself. It's not like bid mass
Okay,
or anything. We're just
yeah.
dealing with the order of the functions. So these,
All right.
in the context of LIATE, are like algebraic.
Okay.